Hi students, welcome to the lab 6 titled File Operations in DOS. Now file operations are very essential to understanding because they are a critical part of any operating system, and particularly I'll emphasize here that they are critical for the functioning of Linux kernel, where everything is a file. The kernel relies on file operations and the file systems to access the hardware, not just manage the data, but even to access the hardware, even to access the USB, it relies on the file systems. So some of the specific reasons why file operations are important in the context of Linux kernel, I'll just list them down. Like, file systems are a core component of the Linux kernel, where it includes supports for a wide range of file systems and providing many protocols like I2C, SPA. Everything is loaded as a file there. Then file operations are used throughout the Linux kernel for many parts of the boot up and the device drivers and the system calls. So there is a course in Bits Pilani for the MTech students called device drivers, where it particularly talks about that how each and every device and has a corresponding device driver, which is nothing but a file in a file system. All right, file operations are in fact important for the security, and they are important for performance and for doing all sorts of input output operations. So with that sort of an introduction of why the motivation behind file operations, understanding file operations, let's get started. So DOS interrupts for file operations. As we had seen last time, the importance of interrupts. Similarly, whenever we are dealing with files, here also we'll raise the DOS interrupt 21, and in hexadecimal 21H. So let's just read this, that disk operating system is an operating system that was widely used in personal computers in the 1980s and the early 1990s, and one of the key features of the DOS was its ability to access files on disk drives. So if you, let's say, that have your microcontroller, so this is your microcontroller, then there are some registers available here, and then there is a file system outside to this, right? And through your different data bus address lines and the control signals, you can read and write memory, you can read and write, do read and write operations on this external memory or the primary memory. So this is very important to understand that all these input output operations which you are doing here have a very deep integration with the file systems, and this is what we'll be covering in this session. So DOS provides a set of interrupts or software interrupts which allows programs to interact with the operating system to access and manipulate the files. These interrupts provide a simple and a standardized way for programs to perform common file operations such as creating, opening, reading, writing, and closing the files. So the DOS interrupts for files are still relevant today, as many programming languages still use DOS style file input output. While modern operating systems provide much more sophisticated file APIs, understanding how interrupts work can be useful for low level file input output operations on older systems or embedded devices. The DOS interrupts are accessed through the, so again, this we had seen last time, interrupt 21H, which is a software interrupt that allows programs to call various DOS services, including file input output. Each file operation is performed by calling a specific function or a sub function using the AH register. Now this is very important, and as far as possible, try to remember which the what is that specific function code which we are using, which we'll put into the AH register. We'll go through ample examples which will give you more clarity. So the other registers are used to pass input parameters to interrupt and receive output values, right? So AH is the fundamental register which will guide that which function it is performing, and other parameters or attributes which are required along with that operation will be passed through some other registers. So let's look at the common DOS file functions which are available. So in DOS, a file handle is a unique identifier. All right, there are two methods. We'll be primarily focusing on the file handle method because it is easier to use and much more practical. The DOS file handle functions are a set of interrupts that allows programs to create, open, read from, write to, and close files using file handles. And there are much more operations that you can do besides just these basic operations. So here are some most commonly used DOS file handle functions. First one is AH3C, like in the AH register. you store 3ch, then 3d, 3f, 40, 3e, 44, 4e. So for 3c, the operation linked is the create file. So this interrupt is used to create a new file and returns a file handle that can be used to access the file. So how does it return? As we had seen in the last slide, it will be returning in some register. So the dx register is used to get that file. We'll just confirm this in the next slide, it's mentioned. So to get the file handle, and now all the other operations like reading from a file, writing from a file can be used using this handle of the file. Opening the file, so this interrupt is used to open an existing file and return a file handle that can be used to access the file. So again, in the same register, you'll obtain, once you execute this command in 21, and in h you put 3d before executing in 21, if in the h it is 3d, and there are some other input parameters like which file you're referring to, then a file handle will be given to you in your dx register. Similarly, there is read from file. So once you have opened the file, then you can start doing the read operations. So how many bytes to read, from where to start reading, etc. All this is captured using the 3fh, and along with some other attributes which are passed in other registers. Write to a file is called by 40h. Closing a file is 3eh. So it's a very simple operation. It does not require any external support, any other attribute. Only the which file handle to be stored, that is the only important thing. And get file information, find file first, find first file. Like if you have a string, we won't be using this, so do not worry, I'm just giving you an overall holistic picture. That specified file pattern, so it returns a file handle that can be used to access the file. And if you not if that specified file pattern is not what you like, the file which is returned is not the file which you're looking for, then you can use another interrupt, which is find next file. So I don't remember the code for that, but you can just execute that and it will find the next file which is matching that pattern. All right. So int 21h, uh, and 3c, creating a file. So here I've written a good description. Here I've written a good description. And in the future commands, I'm not explaining this much, but just since it's the first command which we're explaining, so I've written a lot of information. So let's try to understand this. So is a DOS interrupt used to create a new file? The function code for creating a new file is passed in the AH register, which will be 3C, while other input parameters are passed in other registers as follows. So one we are using is CX, the other one which we'll be using is DX and AL. And if the file exists, the act all right, so if the so what is happening is, first read this line. So if the file does not exist, a new file is created and a file handle is returned in the AX register. The in the previous I mentioned DX, so it is AX register, remember that. The file handle is a unique identifier that is used in subsequent file access operations. If the interrupt fails, the CF flag is set and the X register contains an error code. So what that error code is, all that is specified in the technical reference manual. But few of the important things which we can relate to is CX. What does CX specify? So specifies the file attributes. Whether if before executing this int 21h in the CX it is 00h is loaded, then it means basically in CL, right? So it means that it has to be opened as a normal file. If 01h is loaded, then it will mean that it is a read-only file. If 02h is there, then it's a hidden file, and if 04h is, then it's a system file. So just like in our Windows operating system, which we are all used to, when we right click and make the file as hidden, or there are certain attributes which we can set in the properties panel of that file. So these are some of the file attributes. DX specifies the address of a null terminated string that contains the file name. Yes, so that's why I got confused. So DX specifies the address. So basically, whatever your file name is, it's better that we understand this through an example. But let's say your file name is sample.txt. So this is stored in some memory location, and while you're initializing your data in the dot data segment, you let's say happen to say fname dv sample.txt. So fname is pointing to the first as the base pointer of this. So the dx now you move to this specifies the address of a null terminated string. So null terminated string means that in the end it should contain a zero. That means that that's what is meant by a null terminated string. Then only dx will know where to stop reading the file name, right? So this is the correct way. We'll see through an example, don't worry. That contains the file name. Now ds specifies the segment of the file name, so it's just ds colon dx, nothing special here. I'll quickly go through the other file operations in one quick go. Then we'll jump to the examples. So function 3dh, which is open an existing file. Function 3dh open an existing file. So the input to this would be in the H register you'll store 3D, and in the AL you'll specify the access and sharing mode. So 0 for open for reading, 1 for open for writing, 2 for open for read slash write. So whatever it is, you just specify that into the AL. And in the dx you again load the ASCII z file name. So ASCII z file name simply means that it is a null terminated file, which means, as we discussed last time, that if it is sample.txt, then it would just end with a zero. That's what you have to add it in the end in order to make it a null terminal. ASCII z file name. So the output is that if successful, your EX register will again contain the file handle, and you can take it into like you can move it to a particular handler file name. And EX is, since it's 16 bits, so whenever you're taking, let's say, the handler of the file name in your .data segment. So if you're in your .data segment and you have your file name here as db, and if you have your handle one, let's say handle one, so it will be just a dw, and you can specify a question mark here. So it's just 16 bits handler will be there for the file. And after you've obtained this, after this is successful, you can do move to this handle one the contents of the register ax. And if it is having an error, then error code, depending on what the error code is, it will mean something, but no need to get into those low level details. So function 40h is for writing to a file. So bx, now for writing to a file you need two additional inputs: what has to be written, how many bytes have to be written. So the date number of bytes to write, and the starting address from where things have to be copied into the file memory, into the file. So ax is equal to count of bytes. So all these are going in as an input. Output is ax will tell you count of bytes which are actually written. And if ax is less than your cx, then it would definitely mean an error sort of a situation where your disk is full. And then there are some, if the carry flag is set, and then you need to check your ax flag for figuring out the error code. All these error things are not something which we'll go delve deep into, but these become important when you're writing a software on top of your dos, because writing a software you need your program to exit with proper exit codes for you to realize that okay, where the things have gone wrong. Function 3eh, close a file. So that's a very simple thing, that in AH you load this 3E, and in BX you load the file handle, and the output is just the file is closed. And if the carry flag is set, then you need to check the EX for figuring out the error code. So let's look at an example, creating a random file. Let me take out. All right. So here is the code, and I'll show you the bin file right now before we proceed. The bin folder which we have. Here is our code, and let's create a file with the name. Let's call it test.txt, and let's save this. So be careful that this file name also should not be like too long, or else it throws an compiler error. So try to keep it small, less than 8 characters. So here we have created a file name which we want to create, and the handler, the 16-bit handler which we'll obtain after executing this int21, we'll store it in this handle memory location pointed by the pointer handle. So let's execute this. So in AH, I've moved the 3ch, and in DX, I've load the file name where from like load effective address into the DX file name. Basically, DX is pointing to the address where the T is right now. And it's a null terminated string. That is one important thing that you have to observe. And in CL, you're moving 1H. So moving 1H in CL means that it's a read-only file which you're trying to create here. So let's save this, and I've already have my DOS box open. So let me compile week 6 c1.asm, and let's execute debugx week 6 underscore c1.com. All right, so let's view the contents of the memory location. So till here is where 010D is where our program is supposed to get terminated. So by the way, just you might be wondering that what was this EH4C and N21 all along. So it is very similar to the instruction which you see right now, that in EH you're loading a special character 4C and then you're raising the interrupt. So this basically means that the program has terminated. This is what the significance of these two instructions are. So it's program terminated is also an interrupt. All right, so now I think it would have given you clarity that why you were always seeing EH comma force in the end. That is what is dot exit and end doing to the program. That is, these two things are actually make writing these instructions, move EH comma force and raising an interrupt 21. So let's execute this step by step and observe in our window whether the file is getting created or not, the bin file. All right, so here I should see a text.txt coming once I execute the complete thing. So I'm executing it till int 010D. So as soon as I executed, a test.txt was formed, right? So it has created a file. Try exploring other CL operations which you have, and generally for creating a file we use this one. So next is writing into a file. So let's do another follow along example, this time writing into a file. And what we have here is a file name handle. So let's execute this and see. So the message which you want to write, we have stored here before only, mup rocks, let's say. And the other structure is very similar. So what we are doing here is, first of all, create a file second.txt if it has not been created. So I want to create this file. All right, and once this file is created, I want to open the file. So while opening the file, I want to open it in the right mode. So now the final handle, which is this handle dw here, these 16 bits will contain the opened file handler, not this read only file handler. Okay, so the file will be opened now. And if I raise this interrupt in the handle, this in this handle, the handler will come from the AX. And now I need to write a message. So important steps for you to see, or for you to figure out, is that what am I actually moving into the H register. So when I'm creating the file, I'm moving the 3C. If I'm opening the file, I'm moving the 3D. And if I'm writing a message, I'm moving 40. So based on the operation which you need to do, just segment your code into different parts, and this way you will be very relaxed. And finally, to close the file, I'm moving 3e. All right. So up till opening the file, I hope it is clear that we'll create a second .txt. We'll change the name perhaps, and we'll open the file in the right for the file in the right mode, and the file name will be point given to the dx will be like the pointer to the file name. File names can be very long, right? So dx 16 bits are not sufficient for me to store a longer file name. So therefore I'm just pointing it, and it has to be a null terminated string, again emphasizing on that. Now the message so after this, the file will be opened, and once within opened file, I can move the handle to the bx. 16-bit handle is there, I can move it to bx very simply, and in cx I can load the length of the message which I want to move, right? So count how many of this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are total 10 characters. Therefore, I'm moving in cx 10, or a better way to write this would be 0a h, because in debugx everything is in when we are opening the compiler, everything there will be in hexa. So better here also to write in hexa only. But anyways, it's not that big of an issue. You can write 10 also. Uh, so now uh, the message, whatever thing you have to write. So if you go back to the slides, if you're getting confused like why am I doing all these operations, so just see what all the inputs are. I have to specify I have to give the file handle into the bx register. In the cx I have to specify the number of bytes which I want to write, and the starting point of the from where I have to start writing will be given into this data address, which is ds colon dx. And in the output, I'll see the output, I'll observe the output, and we can see it. So let's run this code now. Week 6 c2. All these things you can find it in github, so please do not forget. And your lab exercises starter code also you can find there. So any change which I have to make, so instead of second, since I've already executed this, either I can delete it. Let's put sec sec.txt. All right, I'm saving, and let's run it. So ml week 6 c2 dot sn. All right, so first thing which we need to observe, so it's as I told you that it's always a good idea to just take a screenshot or save this somewhere. So I'll do that right now. I'll save it with me, or I'll just click a photograph quickly. Right, and so it's not over yet. I see that here it is getting over ah012d. So one option is to execute all of this in one go, which is the preferred method. So we'll execute all of this in one go, and then we'll see that a file name with sec.txt is being created. It is being opened. Once you create, you don't need to open that, like you already have that handler. But just in case that if the file is not there, or if you're trying to open an existing file, then you do not need to create a new file. You can just open the file, and you're writing a message to the file, and the message which you want to write is mup rocks. All right, so that we have specified here. So this is what we want to write into the file sec.txt. This is our objective. So let's go ahead and execute this till. So let's just first of all see the memory locations, right? So where my things are stored. So a file f name, the first thing is f name. So I can see that f name is 0132. So D 0132. So here my file name, f name is there, and then there are dw numbers for 16 bits basically for storing the handle. Then I have mup rocks specified from here, and it's a null terminated string, so you can see that 100 belongs to that null termination thing. All right. So now if I execute, I should see a file sec.txt with me. So g up, I'm executing ah4c, so 012d 012d. Let's see. Here also I saw something getting changed. So sec.txt, I open it and you can see that mup rocks comes. All right. So this is writing into a file. You can try some other things like remove the code of create.file and try and open an existing file which already is there and see what happens. So it's very simple. So I'll do that right now. I'll just comment out this part and let it remain. And instead of mup I'll say mup docs and mup docs and here in the open file, it's I just need to open that file. All right, so control S and compiling and running. Where has it disappeared? H4C21. So 0120 up to 0120 I have to execute this. So G0120. So you can see that the file got updated to mup docs. All right. So it has overwritten that file. Now you can read this file, you can append to this file. There are many things which you can do with, amalgamation of all sorts of these file operations. Now let's look at another follow along example, which is reading from a file. So we want whatever is stored in the file, we want to read from that and we want to bring it to the memory. So like something like, bring it to our data segment somewhere here we want to write, let's say. So for that, let's create a file name with the some thing like user.txt. Just, if I have a list of all the usernames with me, I'll store it as user.txt. And again, it's a null terminating string. And then I'll leave some space for the message. Like this time my message is the variable. So in string operations, one thing important which we had noticed was that whatever be the string, let's say hello also, it has to terminate with the dollar sign for it to, for us to um, know that the string has ended, for the debugx to know that the string has ended, for the microprocessor the instruction to know that the string has ended, and just only these many things have to be, put out onto the screen. So uh, for that we'll open the file user.txt. So this is the code 3D we'll put into the and we'll open it in read format, which is putting 0 into al. Then the file name dx will point to the file name, basically to this u here, and then we raise the interrupt. What we get in output is the handler of the file which gets stored in ax. And in order to save that, because ax can be overwritten any time, so whatever variables which we have to save, do not use ax and all these things as variables. Even if you want to use something as a variable, declare a space for that into the memory and then use it as a variable. So in that case, you're sure at least that variable won't be overwritten, because all these ax, cx, bx, these are very, quickly they keep on shifting. So if you have saved some data in your bx or your ax register, it will get overwritten at this point of time. So it's better to save it somewhere. So that is why we have this handle with us, where we want to save the handler of the file. So we'll move this handler to the handle pointer. After that, we read content into message. So move h 3fh, and so if you have to read the content, we have to provide 3f. And now we had seen some slides back what all things which we wanted to point out. So at this point of time, bx should be carrying the handle, cx should be carrying the number of the count or the number of bytes which you want to read uh, from the file, and the dx should contain the memory location where the uh, message which I load, or the bytes which I load from the file, where will it be loaded, from which point it will be start to load. So that is given by this message here. All right, so dx will contain that. And then I raise the interrupt 21. So all these inputs you need to provide, and then only raising an interrupt makes sense. Without specifying all these things, many things will go haywire in your program and you will not be able to realize what just happened. After that, you already have the f- at this point of time, up till this breakpoint, we'll see that you have the message whatever was there in the file in your um, data segment. If you have to print out that message, it's a simple thing which we had seen last time. Since it's a dollar ending string, that's the smartest if you do. We specified everything with the dollar, and wherever, like, how many bytes are overwritten, after that next thing which will come will be a dollar automatically. We don't need to put any special effort for that. So after that, we'll close the file with ah comma 3h and in 21h. So let's see this in action. Firstly, I have this user.txt. In this, I've just specified, let's say, a name Vrinda, or all right. And I want to bring this to I want to bring this to my user space. So for that, I have this file here with me, and it's exactly the same code which I have there. So I'll just simply execute it now, and we'll do a breakpoint at this point. All right, we'll see that we'll analyze the contents of the memory location at this point. So ml week 6 esm and debugx week 6 3.com. All right, so let me just save. Again, I'll just take a quick photo of this so that I don't miss out the uh, data segment addresses which I have to go back to in order to see things. All right. So at this point of time, if I go to the memory location 012c, 012c, D012c, which is my this first data which I'm loading f name. So it's showing user.txt, and then it's a null uh, ending string. Therefore, there's a 00 coming here. Then two 16 bits, 2 bytes I've left for the handle, and then there are 20 duplicates of dollar. And whatever message I will take from that file, basically the word Vrinda, the name Vrinda will come here, and after that I can print that. So let's go ahead and see that. So executing move al0, all these are sequentially I'm doing. So the file is opened right now. You can keep on checking that in what register what has come. So the file has opened, and in AX you can see that 0005 was there just after I raised the interrupt. So now this is the second interrupt. After this interrupt, we'll check back the memory location which we have. All right. Okay, so now it's the time to go back to 0 1 0 1 2c. So you see that I'm successfully able to bring uh, the user from my txt file to my memory space, and now I can do all sorts of operations on this, like if I have to check it, like if is this user available in my existing database or not, or there might be a separate file with for passwords, or usernames, available usernames. I can take an input from the user and can store it at another memory location, then I can compare these two things. So lot many things are possible with file operations. Only thing is that you have to be very careful in the choice of your codes, and keep on saving. Just the more, I'll say this again, I've said this multiple times, the more efficient your data segment is, the easier it becomes to write your code segment. Okay, the easy, so your data segment has to be like really spot on for you to write a very small and efficient code. So this is the follow along example 3, and with that, it's time for the lab tasks. The lab tasks are simple, so go ahead and check the lab sheet, and you'll find them in the description of this video. The slides will also be made available. So thank you for your time. If there are any queries, please drop me a mail. Thank you so much.